So at this point, you guys know a little bit about independent variables and dependent variables as they show up in a relation between two variables. You'll recall a relation is just some connection that exists between an independent variable, which kind of is the one that runs the show that's represented on the x-axis, and a dependent variable, which depends on what happens with the independent variable. This is the one that does the watching, and this is the one that kind of depends on the other one and what's going on there. So in this example we have here, this is a story where we've got a family imaginatively named the Smiths that went on a picnic last weekend. And in the graph, you kind of see a little history of how far from home they were during that day. So at the start of, well, probably not the day, but I guess probably maybe around, 11 a.m., you see the distance here on the y-axis is at 0 when the time is at 0. And as time moves along this way, this is time passing as we move along the x-axis, then as time goes forward a little bit, you see that the distance, the y-coordinate on all these points, will be getting bigger and bigger. Now, what does that mean? Well, it means that they're getting further away from their house at the start as time passes. Now, what happens at a certain point, let's pretend, this is like noon. At noon, this line showing the distance away from their house becomes a flat line. That means that this number, if you think of this as a y-coordinate, here the y-coordinate is increasing as time goes forward, as the x-coordinate increases. But then, at a certain point, the y-coordinate stops increasing. The x-coordinate is getting bigger and bigger, and the y-coordinate stays the same. What that means is the distance they are away from their house is staying constant for a while. It's not increasing, it's not going up, it's not going down, it's staying the same. And there's a few ways this could happen. One unlikely possibility would be that they get a certain distance away from the house and then they start running in a circle around their house. They're always the same distance from it. More likely what happened is they got a certain distance from the house and then they sat down and they started eating their picnic, right? If time is passing and their distance isn't increasing, then maybe they're just not moving at all. That's probably what happened here. Now, at a certain point, the distance starts increasing again with time here. Now, probably what happened is wherever they were eating, they decided, maybe let's go eat a Dairy Queen. Let's say they're at the park on Jean Mance Park on Park Avenue, and then they say, well, there's a Dairy Queen a little further up Park Avenue. So they go a little further away from their house, and then they stop again, and then they're having a nice blizzard here. Ooh, this is delicious. This is great. And then they start going back home. The distance between them and their house is decreasing as time moves forward. What that means is they're getting closer and closer to the house. And right here, this spot here, they've gotten back home. Because when time at this point is, this is maybe 6 p.m., the distance, the y-coordinate for this point would be 0. That means they're actually at home. And that's what's going on in this story graph, okay? So segment A, they're getting further away from their house as time is passing. Segment B, they're not getting further away. They're staying in one spot. And they go a little further away, they're staying in another spot, and then they're heading back home. One thing I want you to notice here, if you look at the line here at part A, notice how it's going up pretty steeply, and then the line at part D isn't as steep as line A, right? Like if you were snow tobogganing down this, you would go slower down this way. You'd go much faster. This would be very dangerous actually here. What that means is the speed at which they're leaving, going away from their house, is faster than the speed that later on they return to their house. That's something that we'll talk about a lot in this unit called the rate of change, and you can see it showing up on the graph. Okay, now if you can understand the dynamics of that little story that we had with the Smiths going on a picnic, let's see if you can make sense of a couple of other graphs here. Let's say we're looking at a situation like this. I don't know why I'm focused on ice cream so much here, but here, as opposed to the Smith family, now we're looking at somebody with a much more interesting name, this guy John. John is going to the ice cream parlor. So this is a graph here of John's trip to the ice cream parlor. And he's going to ride his bicycle to the ice cream parlor. He realizes that he forgot his money at home. So then he rushes back home for some money and then heads back towards the ice cream parlor. That's the story. We have it set here. Let's look at what it looks like in this graph here. So this graph is meant to be John's trip to the ice cream parlor. I don't know why I can't get it to zoom in. Let's see if this works here. Okay. So this is John's trip to the ice cream parlor. And we already heard the story that he goes to the ice cream parlor. He's on his way there, realizes he doesn't have any money, goes back home, and then gets his money and then sets back out for the ice cream parlor and eats some ice cream. Now, if you're looking at this graph here, again, we've got time as our independent variable along here and distance our dependent variable. This is the distance away from his house. let's see, based on these things here, I'm going to tell you that there are some different events going on during this story. One of them is when John returns to his house after realizing he's lost his money. See if you can figure out where it is that John realizes he forgot his money. I bet you're looking and you're seeing this point right here, right? Because he was going away from his house, realizes he forgot his money, and so then the distance decreases. He's heading back home. At this point here, he's back at his house, right? And now he's found his money. It looks like it took him quite a while to find it. So he heads back out. And then here you see at 5, this line has got a different slope on it. It's not as steep as this one here. And then finally at line 6, he's staying at a constant distance as time is moving forward. The y coordinate here, if you had y coordinates, wouldn't be changing. It's just flat here. Now, I want you to answer a few questions based on this story graph. See how well you can answer them. All right, let's move on to another story. This story features not John or the Smith family. It features Tony and Tony's drive to North Bay, Ontario. So here on this graph, we've got a couple of things showing up. You have the distance in his drive to North Bay. Right at the start, he hasn't traveled any distance yet. On our x-axis, we've got distance in kilometers showing up here for his drive to North Bay. And we see this is showing 300 kilometers. There's 4 boxes. That's 300 kilometers. And then another 4 boxes takes us to 600 kilometers. This is after 900 kilometers, 1200, 1500. And what this story is telling us, this is probably sometime in springtime, right? Because on the y-axis here, what we've got are the measurements that are showing up in the little thermometer that's inside Tony's car, telling him what the temperature is outside the car in Celsius, degrees Celsius. So at the very start, when he leaves his house on his way to North Bay, it's 4 degrees Celsius. And after 300 kilometers, it's now halfway between 6 and 8. That's going to be 7 degrees Celsius. And then I guess things start getting colder at a certain point to where it's right here, halfway between 300 and 600. That's 450 kilometers. This is at its coldest here, 3 degrees. And then it slowly gets warmer until it's at this point here, halfway between 900 and 1200, which would be 1050 kilometers. And then at the very end of his trip, starts getting a little bit colder again. Okay, so what I want you to do now is, based on this graph, I want you to interpret some of the information in this graph and answer a few questions for me.